Alright, this is Chemistry Basics video number 3, the last and final one. We will finish talking a little bit about symbols and formulas and good old periodic table, which we'll discuss quite a bit in this class. Okay, so each element on the periodic table has a symbol, right? We have this big periodic table down there. You don't have to memorize it. You're going to learn a lot about it during the year. And these symbols make it easier to write chemical formulas. So we will get to know those symbols very well. We will use a lot of them this year. But it kind of reminds me of a state, right? So the letters for Utah are UT, right? That's simply an abbreviation for Utah. Kentucky is KY. It's the same with the periodic table. Those elements on there are shortened by their symbols. Chemical formulas, which is what we're going to look at right now. So a good example is our favorite. What we're made a lot of is H2O. So water tells us, that chemical formula tells us what elements are in the compound. We have hydrogen and we have oxygen, and the proportions or numbers of atoms of each element. So this hydrogen has this water has 2 hydrogens and it has 1 oxygen. So again, we can take both these examples and look at it. We see right here, we see 2 hydrogen, and as we'll see in a second, if there's no number there, that's an understood 1. It's like math class, right? Carbon, we have 1 of them, and hydrogen, we have 4 of them. We call that molecule a molecule of methane. So CH4 is methane. And one you should know from biology class, we have 6 carbons here, we have 12 hydrogens, and we have 6 oxygens. We call that molecule glucose. Super, so there's symbols, formulas. We'll keep moving on here. Let's talk about this big guy, right? That looks a little bit intimidating, but we can break this down and we can have some rules for here, and we can talk about counting these atoms. So the first rule is that the symbol tells you the element. We just talked about this. So we have hydrogen here, we have nitrogen, we have oxygen, we have carbon, hydrogen, oxygen. So the symbol tells us the element. No subscript next to the element means there's 1 atom. So I'll go over here, and right here there's an understood 1 right there, right? So no subscript means there's 1 atom. Any other subscript means that there are that number of atoms. So if I go up here, I know that there are 5 oxygens here. There are 10 hydrogens here, right? That tells me the number of atoms. A subscript outside the parentheses means that there are that many of the thing in parentheses. What does that mean? Well, let's look at this one here. We have parentheses around NO2. That tells me that there are 3 NO2s, right? So there are 3 NO2s. That's important. And then a math term that we'll use in chemistry a good bit this year is coefficient. So that number in front of the compound means that there are that number of molecules of a compound. So what does that mean? Let's actually look at water right here. So that tells me that there are 3 waters. Whatever's in front of that 3 means that there are that many of that number. So those are the rules. I know that may not mean much right now, but let's look at some examples of this and put this to work. So let's count the atoms. I'm going to start with this first thing you see up there, and I'm going to start with 3HNO3. Okay, so let's hope I have room to write all this down. I'm going to write this down again, HNO3. So let's count through these. Okay, so hydrogen is what I'm going to start with. How many hydrogens do I have there? Well, there's an understood 1, but we have this coefficient in front, and here's the rule. The coefficient is like the distributive property in math. It distributes to whatever is in front of this. So I'm going to take 3 times that understood 1, and that tells me there are 3 hydrogens. I'm going to do the same to nitrogen. I'm going to take that 3, distribute it to the understood 1 right there. There are 3 nitrogens, and then oxygen. We have a subscript 3 here. and we have a coefficient 3 here, so normally this would just be 3 oxygens, but since this coefficient is there, we distribute it, and when we distribute, we multiply. There are 9 oxygens there. Okay, moving on. This next one's easier. C6H10O5. I don't have any coefficients, I just have subscripts, so I have 6 carbon, I have 10 hydrogens, and I have 5 oxygens. Let's look at the other side of the arrow, the bottom. I have C6H7, and here's our parentheses that always give us a little bit of fright, NO2, and O5. Okay, let's start with carbon. Easy, I just have 6 of them, coefficient there. Hydrogen, I have 7 of them, that's pretty easy. Let's look at nitrogen. How many do I have? Okay, so I would normally have 1 there, but we know this subscript is similar to the coefficient in that it distributes to whatever is inside it. So I now have 3 nitrogen. And oxygen. Oxygen is weird. I have oxygen here and I have oxygen here. This 3 distributes to the 2, so that's 6 oxygen, plus our 5 we have hanging out there, we have 11 oxygen. And finally, we'll do down at the bottom, 3H2O is our last compound there. This 3 is going to distribute to everything in front of it, so that's going to give us 6 hydrogens, and it's going to give us 3 oxygens. So that's how we count those atoms. All right, so to sum it all up, one of our biggest things this year is the law of conservation of mass. I always say we don't live at Hogwarts. This isn't Harry Potter's. I can't create things. I can't just say lumos and create light, and I can't destroy things, right? That's not how our Earth works. So the law of conservation of mass says this: matter cannot be created nor destroyed, right? We can't just take something out of nothing. So during any chemical reaction, the mass of the reactants is always equal to the mass of the product. So I need to say that anything that we start with in a chemical reaction we call the reactants, and anything we finish with is called the products. So the reactants are always going to be on the left, the products are always going to be on the right. And I like this airplane drawing as well because it says the same thing, right? What we start with, though it may be in a different form here, is what we finish with. All those parts on the airplane on this side are here, but it's just a finished product. And here's a great diagram of it. We start with 1, 2, 3, 4 hydrogen on the left side. Well, guess what? I still have 1, 2, 3, 4 hydrogen on the right side. I start with 2 oxygen, 1, 2 on the left side, and guess what? I still have those 2 on the right side. They're just in a different form. That is the law of conservation of mass.